Now Eclipse comes with a debugger that gives developers powerful tools for examining the internal state of a running application. And this can be useful, of course, when you have a bug in your application and you're not sure exactly what's causing it. So let's use the Eclipse debugger to examine an application. Here I'm showing a simple Android application that I've named The Answer. And this app is supposed to show you the answer to life, the universe, and everything, which, as the Hitchhiker's Guide to the Universe tells us, is 42. As you can see, however, instead of displaying 42, this app says, we may never know. So clearly there's a bug in here somewhere. Let's use the debugger to track that bug down. So here we are in Eclipse. First, I'll open up the Answer application and show you its source code. Now the truth is that this is a pretty silly program, and the bug will be fairly obvious once you've looked at the code. But my goal here is to show you the debugger, so just between us, let's pretend that we don't really know what the bug is. Now you can see that there's an array called answers, through which the program will search, looking for the answer 42. There's the onCreate method, that is the starting point when the class is executed. Inside onCreate, there's a call to a method called findAnswer, and findAnswer is listed down below. Now findAnswer is supposed to search the answers array and return the number 42 if it's in there, or -1 if it's not. The program stores findAnswer's return value and then uses it to compute a string called output. And finally, the program displays the output string. So since I don't know where the bug is, I decide to use the debugger to debug the program. And the first thing I'll do then is to set a breakpoint that stops the program when it enters the onCreate method. Now instead of running the program, I'll debug it by right-clicking the project name, selecting Debug As, and then selecting Android Application. I'll click OK, and when the application reaches onCreate, it stops and shows me the debug view with the current line highlighted in the source code. Now at this point, I'll step through the code line by line, examining the program's state. To step forward, I select Step Over from the toolbar, which advances the program one line. I'm now at the line that calls findAnswer and stores the return result in the variable val. Once I step over this line, you'll see that the value of the variable val is now -10, which is already a problem. It should have been 42. So the problem is certainly down there in the findAnswer method. So let's look more closely at findAnswer. And to do that, I'll put a breakpoint at findAnswer and then restart the application. Now this time, when the application stops at onCreate, I'll hit the Step Over button, which will let the application continue executing until the findAnswer breakpoint is hit. I can step forward in this method and examine the values of variables to determine that 42 is indeed in the array, and that findAnswer sees it but considers it the wrong answer. Anyway, as I'm sure you've figured out long ago, the problem is that I'm accidentally checking for not equals rather than for equals equals. So I'll fix that and start over, and this time we'll see the correct behavior. Now just to make sure, let's go back and fire up the answer. And yes, the answer to the life, the universe, and everything is again 42. Now I think debuggers help most when you have a reasonably good idea of where your problem is, so you can focus in on a few lines of code. But in many other situations, that kind of low-level instruction by instruction examination that debuggers are so good at supporting is less helpful. Instead, it may be better to use more general tools that instrument your system and let you monitor its behavior as it runs over time. Android provides a number of these monitoring tools in its Dalvik Debug Monitor Service, or DDMS. Today I'll talk about 4 of these tools: a File Explorer for viewing a device's file system, Logcat for logging and displaying runtime events, TraceView for displaying method execution traces, and Hierarchy View for examining user interface layouts. Let's look at these tools and see how you access them from Eclipse. First, let's open the DDMS perspective, which exposes a number of panes and buttons for accessing the different DDMS tools. We now see a device pane that shows the devices that are currently connected and shows a list of debuggable processes running on these devices. The first tool we'll look at is the File Explorer. This view shows you the files on your file system. For example, here we see that this device has a /data/data directory in which applications can store their persistent data. This device also has an external memory card. And there's some directories there for storing music and movies and other things. The next pane I'll talk about shows the Logcat view. Android logs many events by default. That is, as the software runs, it spits out information about the things that are happening on the device. And this information is stored and can be displayed in the Logcat view. Android also provides methods that let developers log their own information. Another DDMS tool is TraceView. TraceView allows you to trace the methods that your application calls. Let's do this for the answer application that I showed earlier. So this is the source code for the application. And to simplify my demonstration, I'll first put a breakpoint in the onCreate method, and now I'll start debugging the application. Now, as you can see, it stopped at the breakpoint, and now I want to start profiling. So I'll open the DDMS view, and click on the button that says Start Profiling. And now I'll return back to the debug view and resume the application. I'll let the program run for a while, and now I'll return to the DDMS view and press the same button as before, this time to stop the profiling. At this point, TraceView will process the trace information and show it to me graphically. The TraceView display shows 2 panels. One is a timeline view showing each method call's sequence and duration. The other is the profile view, which shows statistics and other information about each called method. Let's look for our old friend FindAnswer. When I click on FindAnswer in the profile view, I can see where it was called up in the timeline view. And now I can zoom in on the timeline to see more information and surrounding context. And if I want to be more precise in my profiling, Android also allows me to insert statements directly into the program that enable targeted tracing. And doing this requires that you set some permissions, however, for your application. And we haven't talked about permissions yet, but we'll talk about them in a later lesson. And finally, on my Mac, if I command click on FindAnswer in the profile pane, Eclipse will take me to the file containing that method. The last tool I'll talk about today is the UI hierarchy view. This tool allows you to analyze your application's user interface and understand how it's organized. For example, let's look again at the Hello Android application. First, Let's run the Hello Android application. And once it's up and running, we'll go to the menu bar and select Window, then select Open Perspective, then select Hierarchy View. Now if you don't see it, try selecting Other and searching there instead. Now once the Hierarchy Viewer starts, we'll go to the Window panel and double-click the entry corresponding to the Hello Android application. It's the one that has the words Hello Android in it. Now, double-clicking on this entry will bring up a graphical representation of Hello Android's user interface, which, like most user interfaces, is organized in a hierarchy. For instance, there's an outermost application window, which holds the entire user interface. It contains two children, a title bar and the large rectangular body of the application. Each of these in turn contain further elements. Here I'll click on the outermost window and I can inspect detailed information about that window, such as its layout parameters, which for example shows how big the window is in pixels. The region occupied by each element is shown here in the layout view in the bottom right corner. And the same information is also available for the title bar, and the same for the body and the text view that it contains. Now that's all for today's lesson on the Android development environment. Please join me next time when we'll discuss the fundamental building blocks of Android applications. Thank you.